Imagine a distant world, a frozen wasteland of ice and rock, bathed in the eerie red glow of a distant sun. A place where the mysteries of the outer solar system collide, where methane oceans freeze beneath towering mountain ranges, and a thin atmosphere whispers secrets of the planet's past. Welcome to Makemake, the icy red world that's like nothing you've ever seen before. Join us on a journey to this distant dwarf planet, where we'll explore its rugged terrain, unravel its secrets, and discover the mysteries that lie hidden within its icy depths. Are you ready to take the plunge into the unknown? Makemake is a dwarf planet in the outer solar system. It was the fourth body identified as a dwarf planet and was one of the bodies that caused Pluto to lose its status as a planet. Makemake is large enough and bright enough to be studied by a high-end amateur telescope. Astronomers took advantage of the dwarf planet's recent passage in front of a star, called an occultation, to determine that Makemake has no atmosphere. Discovery and naming. Makemake, pronounced Maki, was first observed in March 2005 by a team of astronomers at the Palomar Observatory. Officially known as 2005 FY9, the tiny planetoid was nicknamed Easter Bunny by the group. The team was also responsible for the discovery of the dwarf planet Eris, and was involved in the controversial discovery of the dwarf planet Haumea. Makemake is named the god of fertility in Rapa Nui mythology. The Rapa Nui live on Easter Island in the southeastern Pacific Ocean. Makemake was the chief god, the creator of humanity, and the god of fertility. Orbit, size and characteristics. Makemake is the second brightest known object in the outer solar system, just slightly dimmer than Pluto, at 870 miles, 1,400 kilometers, wide. It is about two-thirds the size of the more well-known dwarf planet. It orbits beyond the range of Pluto, but closer to the Sun than Eris, taking approximately 310 Earth years to circle the Sun. Makemake is reddish-brown, leading scientists to conclude that it contained a layer of methane at its surface, possibly in pellets 1 centimeter across. Signs of frozen ethane and frozen nitrogen have also been determined. Like all of the known dwarf planets but Ceres, Makemake travels through the Kuiper Belt, the region of ice and rock at the outer edges of the solar system. It can travel as far out as 53 times the distance between the Earth and the Sun, and come as close as 38 times throughout its orbit. Makemake spins on its axis once every 22.5 hours, with a day just shorter than Earth's. Brightness. Makemake is currently visually the second brightest Kuiper Belt object after Pluto. Having a March opposition apparent magnitude of 17.0, it will pass from its present constellation Coma Berenices to Bootes in December 2027. It is bright enough to be visible using a high-end amateur telescope. Combining the detection in infrared by the Spitzer Space Telescope and Herschel Space Telescope with the similarities of the spectrum with Pluto yielded an estimated diameter from 1,360 to 1,480 kilometers. Spectra and surface. Makemake is a dwarf planet located in the outer solar system, beyond the orbit of Neptune. As a relatively small and distant world, the surface of Makemake is largely unexplored, and little is known about its exact characteristics. However, observations from Earth-based telescopes and spacecraft flybays suggest that Makemake has a heavily cratered surface, similar to other icy bodies in the outer solar system. Its surface is likely composed of a mixture of rock and ice, with frozen methane and other volatile compounds covering much of its surface. Some areas of Makemake's surface may be covered in darker material, possibly the result of organic compounds or other complex molecules. Additionally, recent observations suggest that Makemake may have a thin atmosphere composed primarily of nitrogen, which could have important implications for the planet's surface processes and geology. Further exploration and study of Makemake will be necessary to fully understand the nature of its surface and the processes that shape it. Magnetosphere. Unlike larger planets, such as Jupiter and Saturn, which have powerful magnetic fields that shape their environments and protect them from harmful radiation, Makemake is likely to have a weak or non-existent magnetic field. This means that charged particles from the solar wind are free to interact with the planet's atmosphere and surface, potentially causing a range of atmospheric and surface processes, such as ionization and atmospheric erosion. However, due to the lack of detailed observations of Makemake's magnetosphere, it is difficult to say with certainty what the exact nature of these processes may be. Future studies and exploration of Makemake may shed more light on the planet's magnetic environment and how it interacts with the surrounding space. Atmosphere. Makemake was expected to have an atmosphere similar to that of Pluto but with a lower surface pressure. However, on 23 April 2011, Makemake passed in front of an 18th magnitude star and abruptly blocked its light. The results showed that Makemake presently lacks a substantial atmosphere and placed an upper limit of 4 to 12 nanobar on the pressure at its surface. The presence of methane and possibly nitrogen suggests that Makemake could have a transient atmosphere similar to that of Pluto near its perihelion. Nitrogen, if present, will be the dominant component of it. The existence of an atmosphere also provides a natural explanation for the nitrogen depletion. Because the gravity of Makemake is weaker than that of Pluto, Eris, and Triton, a large amount of nitrogen was probably lost via atmospheric escape. Methane is lighter than nitrogen, but has a significantly lower vapor pressure at temperatures prevalent at the surface of Makemake, 32 to 36 K, which hinders its escape. The result of this process is a higher relative abundance of methane. However, studies of Pluto's atmosphere by New Horizons suggest that methane, not nitrogen, is the dominant escaping gas, suggesting that the reasons for Makemake's absence of nitrogen may be more complicated. Why no moons? Makemake has not been observed to have any companions in orbit around it. This is in contrast to some other dwarf planets in the outer solar system, such as Pluto and Eris, which both have multiple moons. The absence of moons around Makemake may be due to a variety of factors, including its distance from the Sun, the composition and density of its surface materials, and its history of gravitational interactions with other bodies in the Kuiper Belt. However, as our understanding of the outer solar system continues to improve, new observations or discoveries may reveal the presence of previously unknown moons around Makemake or other dwarf planets. In conclusion, exploring Makemake and the other icy worlds of our solar system is crucial for advancing our understanding of the universe and our place within it. These distant and mysterious worlds hold many secrets and have the potential to unlock new insights into the formation and evolution of our solar system and beyond. As we continue to send spacecraft and telescopes further into space, we will undoubtedly discover new wonders and expand our knowledge of the universe in ways we never thought possible. If you found this video informative, make sure to hit the like button, share it with your friends and family, and subscribe to our channel for more exciting content like this.